Hey everyone, and welcome. Today we're diving into an explainer on something you have absolutely felt before, but maybe haven't completely broken down yet: occupational vibration. We're going to take those dense European directives and complex physical measurements and translate them into a clear, actionable plan for occupational health and safety. If you've ever operated heavy machinery, or if you're the one managing the safety of the folks who do, you already know that vibration isn't just some minor annoyance. It is a powerful, highly destructive physical force. So let's master exactly how to manage it.
Here's our roadmap for today's explainer. 1. Vibration legislation and standards. 2. Managing EAV and ELV. 3. Measurement rules and instruments. 4. Calculating daily vibration exposure. 5. Vibration and the human body. And finally, 6. High-risk industries and tools.
Section 1. Vibration legislation and standards.
Okay, to really understand workplace vibration, we have to start at the very top with the legal framework. Right at the peak of the hierarchy, we have the EC Vibration Protection Directive 2002/44/EC. Think of this as the big, overarching legal umbrella. From there, the rules branch out into very specific ISO standards depending on what kind of exposure you're dealing with. For hand-transmitted vibration, we rely heavily on ISO 5349. But for whole-body vibration, say you're sitting in a massive bulldozer all day, we switch over to ISO 2631. And anchoring this entire system at the foundation is ISO 8041. That one is absolutely crucial because it strictly governs the measuring instrumentation itself. You can't just grab any random tool to measure this stuff. Your hardware literally must meet this standard to be legally and scientifically valid.
Moving right along to Section 2, Managing EAV and ELV.
To successfully manage exposure, you've got to understand what we like to call your vibration budget. You'll want to memorize these numbers because if you're an employer, an engineer, or a safety professional, keeping your workers below these exact thresholds is basically your ultimate goal. Notice how the limits are split up between hand-arm vibration and whole-body vibration. For hand-arm, the exposure action value, or EAV, is 2.5 meters per second squared, and the absolute limit value, the ELV, is 5.0. But look at whole-body vibration. The numbers drop significantly. We're talking 0.5 for the action value and just 1.15 for the limit. Why? Because sending aggressive vibrations through the entire human core, rattling the spine and internal organs, becomes highly hazardous at much lower intensities than when it's isolated to just the hands and arms.
Let's make sure we define these terms crystal clear. Think of the EAV as the caution zone of your vibration budget. The EC directive standardizes this as a daily amount of exposure over an 8-hour period. Once a worker crosses that 2.5 meters per second squared threshold for hand-arm vibration, a massive red flag goes up. As an employer, you can't just ignore it. You are legally required to step in and take definitive documented action to bring that exposure down.
Then we have the ELV. This is your absolute hard maximum limit, no exceptions. Hitting this number represents a remarkably high risk of injury. Workers must never, under any circumstances, be exposed to anything beyond 5.0 meters per second squared for hand-arm vibration on a single day. If they hit it, work stops. Period. It's a strict ceiling designed specifically to prevent severe, irreversible physical damage.
So, what actually happens if that EAV caution budget gets exceeded? Well, employers have to immediately launch a comprehensive program to fix it. First, look at alternative working methods. Can we automate this job? If not, you've got to provide auxiliary equipment, like vibration dampening gloves or specialized suspension seats for your vehicles. Crucially, and this is a big one, you must implement strict maintenance programs. This is where machine condition monitoring really shines. Monitoring a machine's vibration signature doesn't just protect the worker. It tells you if the machine itself is failing. A bad bearing causing excessive rattling is bad for the equipment and the operator. Add in proper worker training, legally capping the task duration, and forcing strict rest periods, and you have a solid toolkit to get those exposure numbers safely back in the green.
Let's jump to Section 3, Measurement Rules and Instruments.
If you're out in the field actually grabbing these numbers, there are some hard and fast rules you absolutely have to follow. First, as we touched on earlier, your instrument must conform to ISO 8041. Second, vibration doesn't just buzz back and forth in a straight line. It moves chaotically in 3D space, so you have to measure in 3 orthogonal directions simultaneously, the X, Y, and Z axes, to capture the true peak acceleration. Third, placement is everything.
The sensor has to be mounted as close to the center of the handle as possible, but without getting in the way of how the worker normally uses the tool. And finally, here is a rule you can't forget. For machines held with both hands, like a chainsaw, you measure each hand separately. You don't average them out, ever. You determine the worker's exposure by taking the higher value of the two. We always evaluate based on the highest point of risk.
Section 4. Calculating daily vibration exposure.
Let's do some math because this is how we figure out the actual risk. It all starts with the total vibration value, which we call AHV. Because we measured in 3 different directions, we have to combine them into one single intensity score. We do this by calculating the vector sum, which is the square root of the sum of the squares of the interval root mean square values from our x, y, and z axes. Basically, the AHV represents the raw combined physical intensity of the tool while it's running. Let's picture a quick calculation. Say your x-axis RMS is 2, your y is 2, and your z is 1. You square them to get 4, 4, and 1. Sum those up to get 9. The square root of 9 gives you a total vibration value, or AHV, of exactly 3.0 meters per second squared. Now, the source material does note a really interesting caveat here. If you're stuck only being able to take a single axis measurement, you have to multiply that result by a safety correction factor ranging from 1.0 all the way up to 1.7, just to estimate this true total value.
But raw intensity isn't the whole story, right? We have to factor in time, and that brings us to the daily exposure, known as A8. We calculate A8 by taking that raw intensity, the AHV we just found, and multiplying it by a time factor. We normalize the actual duration the worker uses the tool, called TE, against a standard 8-hour reference period. So if that tool with a 3.0 AHV is only used for 2 hours out of an 8-hour shift, you plug that into the formula to find their true daily exposure. The brilliant part of the A8 standard is that you don't need to stand there measuring a worker for 8 hours straight. You can take short-term measurements during representative tasks, plug the intensity and expected duration into the formula, and accurately predict their legal daily exposure. It's a total game changer because it lets you directly compare a crazy intense 30-minute job with a mildly vibrating 6-hour job on the exact same legal scale.
Next up, Section 5, Vibration and the Human Body.
This is where things get incredibly real. Think about the human body as a mechanical model. Just like a suspension bridge or a skyscraper, the human machine has specific regional resonant frequencies. For instance, a seated person's spinal column resonates in an axial mode at about 10 to 12 Hz. The shoulder girdle vibrates between 4 and 5 Hz. And incredibly, the entire chest wall will literally resonate wildly when exposed to vibrations between 50 and 60 Hz. When a machine outputs vibrations that perfectly match these natural frequencies of the body, the energy transfer is completely maximized, and the physical damage to tissues, joints, and internal organs is severe.
When those high-energy frequencies are aggressively transferred through the hands on a regular basis, the human body simply breaks down. We aren't talking about being a bit sore after work. We are talking about permanent injury. The primary conditions include vibration white fingers, which is a terrifying vascular condition where blood flow to the extremities is fundamentally disrupted, and the broader hand-arm vibration syndrome, or HAVS, encompassing serious nerve, joint, and muscle damage. It's really crucial to understand the average latent periods for these diseases. Depending on the intensity, it can take anywhere from a few months to several years of daily exposure before symptoms even appear. On top of that, excessive vibration is a massive contributor to carpal tunnel syndrome, causing severe nerve compression in the wrist. And the treatments for carpal tunnel, they range from wearing splints and taking heavy anti-inflammatories to requiring highly invasive surgery just to relieve the pressure. Once these occupational diseases take hold, they are generally irreversible. And that is exactly why those ELV and EAV limits are so strictly enforced by law. There's no going back once the damage is done.
Section 6. High-risk industries and tools. Let's ground all this theory in the real world. Jobs requiring the regular use of vibrating equipment span a massive range of our core infrastructure. If you're managing safety for road and railway building, your workers are at high risk. The same goes for the concrete industry, general construction, heavy engineering, and sheet metal fabrication. It's also everywhere in forestry, foundries, mines, quarries, and public utilities. Basically, if your industry builds or maintains the physical world around us, your workforce is more than likely on the front lines of hazardous daily vibration exposure.
And when we look at the specific equipment being used, we see the usual suspects. Tools like grinders, sanders, jigsaws, chipping hammers, and chainsaws consistently rank as incredibly high vibration equipment. When conducting these hand tool measurements, sensors are often literally taped or wired directly onto the handles to capture that crucial AHV data accurately while the tool is cutting or grinding. These specific tools, if they're used continuously,
will eat up a worker's daily exposure budget incredibly fast, hitting that 2.5 EAV action limit way quicker than you might assume.
So, we've covered the whole shebang: the strict EU directives, the precise ISO measurement rules, the daily A8 math, and the very real threat of permanent conditions like hand-arm vibration syndrome and carpal tunnel. Knowing the harsh physical realities of how the human body resonates and the strict legal framework designed to protect it, is your current condition monitoring program actually keeping your workers in the safe zone? Are you just guessing, or do you have the hard data to prove it? Keep asking those tough safety questions and ensure those exposure limits are never just numbers on a page. Thanks for joining me on this explainer, and stay safe out there.